Today's lesson is on estimating sums and differences for decimals. So students will round decimals to the nearest one, so the nearest whole number, tenth, hundredth, or thousand, and students will round to the nearest whole number, tenth or hundredth, to estimate sums and differences. So let's just jump right in. So which whole number is closest to this number here? So we have 1.0 or 2.0 as the whole numbers. So which number is 1.3 closest to? Well, it's closest to 1.0. Now, if I also give you the number 1.8, which whole number is 1.8 closest to? Well, it's only 2 jumps away from here, or it's 8 jumps away from here. So 1.8 is closer to 2.0. Let's now look at 2.1. So which whole number is closest to 2.1? Am I going to round down to 2 or round up to 3? Well, 2.1 is closest to 2.0, so I would round down. Let's look at this last one. We have the number 2.6. So which whole number is 2.6 closest to? Is it 2.1? Or sorry, 2.0 or 3.0? Well, it's only 4 jumps away from 3.0, so 2.6 we would round up. So sometimes people think of a number in terms of the closest whole number because they don't need to be precise at that time, and whole numbers are much easier to work with than decimals are. So this process here is called rounding. We've already done rounding this year just with whole numbers rather than decimals. So here's some exercises for you to do on your whiteboard. I've given you the number line at the top here if you need it. So you're going to round to the nearest whole number. So 1.4, for example, is here on the number line. Is it closest to 1.0 or 2.0? 1.4 is closest to 1.0. So the answer here is going to be 1.0. Do B, C, and D on your whiteboards, and then you're going to continue on with your screencast. Now, if I wanted you to round to the nearest whole number 3.7, so 3.7 would be between 3.0 and 4.0. Which one is it closest to? Well, 3.7 is going to be closest to 4.0. It's only 3 jumps away. What about 9.4? Would 9.4 be closer to 9.0 on the number line, or would it be closer to 10.0? Well, it's going to be closer to 9.0. Here are some exercises for you to do on your whiteboard. You're going to round to the nearest whole number. When you're done A through H, you're going to resume your screencast. Okay, now on your whiteboards, you're going to place the decimals in the correct table column on your whiteboard. So you're going to create a table on your whiteboard closer to 3.0, closer to 4.0, and I want you to sort these numbers. When you're sorting them, I want you to think about which digit you're looking at in the number to decide where to sort it. When you're done, you're going to resume your screencast. This is what your table should have looked like if you sorted this on your whiteboards. So when you were sorting, I asked you to look at to think about which digit you were looking at to decide this. So when you were sorting these numbers, whether you knew it or not, you were always looking to the digit to the tenths number to decide where to sort it. So we have a rule when we're rounding decimals, just like when we're rounding whole numbers. So our rule is that when the tenths digit is 0, 1, 2, 3, or 4, we round down. When the tenths digit is 5, 6, 7, 8, or 9, we round up. So just like if they're whole numbers like we were doing before, 0 to 4 you round down, 5 to 9 you always round up. So the rules are the same, but instead of looking at the whole number, we're looking at the tenths place for the decimal. You're going to need to remember these rules as we move on. So here I want you to complete these exercises using that rule we just talked about. So I'm going to look to the tenths digit. It's a 5. It's going to tell me to round up. So that tells me that 4.57 is closer to 5.0 whole number, not 4. So it's closer to 5. I want you to do B, C, D, and E on your whiteboards. Then you're going to resume your screencast. So is 3.50 closer to 3 or to 4? So numbers less than 3.5 we know are rounded down to 3, and numbers more than 3.5 are rounded to 4. So 3.5 is actually not closer to 3 or to 4. It's dead smack in the middle. But we always know that a 5 always tells us to round up. Even though it's in the middle, we always round up. So looking back at our table, where are the other decimals with the tenths digit 5? They're all closer to 4. So with the 5 in the tenths place, we always round up. So again, when a decimal is equally close to both whole numbers, you round up. So here you're going to round to the nearest whole number. When you're done these exercises, you're going to resume your screencast. Here's some more exercises for you. You're going to round to the nearest whole number by looking at the tens digit. When you're done, you're going to resume your screencast. So we use the same rule to round decimals as we do to round whole numbers. So if I want you to round 2.365 to the nearest tenth, your first step is to underline the digit you are rounding to. So we're rounding to the nearest tenth. So we're going to underline the digit in the tenths place. Then we're going to put our pencil on the digit to the right of the one we're rounding to. So this is the digit to the right. It is a 6. So the 6 is telling us that we need to round. So I'm going to put R. We need to round up. A 6 tells us to go up. Then you're going to round the underlined digit up or down according to the instruction that we've written. So we have told us, or we've told each other, I guess, we're rounding up. So the 2, this 3 is going to round up. The 2 doesn't change. The 2 stays the same because we're not rounding that number, rounding the number that's underlined. If we're rounding up, this 3 is going to become a 4. And then we're actually going to just leave these boxes blank. You don't need to fill this in with 0, 0 because 2.4 would be the same as writing 2.400. So we don't even need to write the zeros like we do. So we would say that 2.365 is closer to 2.4. Now let's do some practice exercises here following these rules. Round to the underlined place value. So I have 13.451. I want to round to the 4. So I'm going to look to the next digit, which is a 5. A 5 tells me to round up. So the 13 stays the same. The 4 is going to be what's changing. The 4 is what is underlined and it's going up. So 5, that's all I do. If you really want to, you can write 0, 0. But you don't need to because it's the exact same thing as writing 13.5. I want you to do B, C, and D on your whiteboards, and then you're going to continue on with your screencast. So now let's round 2.965 to the nearest tenth. So I'm rounding to the nearest tenth. I'm going to underline the 9. The 9, we now look to the 6. The 6 is telling us to round up. So can this change to a 10? Can I have 2.10? Well, now I need to regroup. So I need to take this 10 and I need to add it to the whole number. So this is going to become a 3. This is going to become a 0. There's nothing left here because I've regrouped it as a whole number. So 2.965 is closer to 3.0. So you're going to complete this exercise here, rounding to the stated place value using grid paper. So if you need your journals, you can, or you can use your whiteboards if you think you're good at that. So 43.6898, you're rounding to the nearest hundredths. So the hundredths is here. So what you're going to do on your grid paper, you're going to write it in 43.698. I'm rounding 43.698 to the nearest hundredths. I'm going to underline the digit in the hundredths place, which is the 9. Look to the digit to the right, which is 8. That's telling us to go up. So I'm going to then round to 43 decimal. This 9 is going to round up. This has to then become a 7. So 43.70. I want you to give B, C, D a try on your own, and then you're going to resume your screencast. So we can check whether the answers to sums and differences are reasonable by rounding to the nearest whole number. So if we have 162.34, I'm going to look to the digit to the, I'm going to round the ones digit. So I look to the 3 it tells us to round down. So 162 is closest to 162.0 plus 16.2. I want to round the 6. The 2 tells us to round down, so this just stays as 16. So I then have 162 plus 16, which is a lot easier to add than these decimal numbers. It equals 178. So if somebody punched these numbers into a calculator and got these answers, are they reasonable? So we're going to check with estimating. So 23.52 is closest to 24. We round, this tells us to round up. Plus 11.18, the 1 tells us to round down, so it stays at 11. So 24 plus 11 is going to equal 35. So is this reasonable? The answer is yes. They're very close to each other. Let's look at B. It's 387.52. This tells us to round up, sorry. So 388 minus, look at the 3, it tells us to go down, so 53. This is equal to, so I need an algorithm to do this, so 388, 53 underneath, lining up the digits, so 8 minus 3 is 5, 8 minus 5 is 3, 3 minus 0 is 3. Wow. So the answer is 335. So is this reasonable? The answer is no, it's not reasonable. These answers are very different. So for estimating sums and differences of decimal numbers, you can round to various place values, the nearest 10, 1, 10th, 100th, and so on. So we're going to reflect on whether their estimate will be higher or lower than the actual answer. So for example, let's consider this problem. Nika had $15.87. He paid $11.02 for a book. Approximately how much does he have, and how much does he have exactly? So what we're going to do is we're going to take this $15.87, which is approximately $16, and we're going to subtract 11. So he has approximately $5. Exactly, he has approximately $5, but if we want to know exact, then we need to line up our decimals. So 15.87 minus 11.02. I'm going to subtract. He has exactly 85 cents. $4.85. So our answers are very, very close. Here's some exercises for you to estimate the answer. There's A and B. When you're done, you're going to resume your screencast. And then here is C and D. Once you have the answers for C and D on your whiteboard, you can resume your screencast. You took the time to answer those 4 word problems on your whiteboard. Here are your answers. The answer to A is yes. She does have enough money to buy all 3 items. The answer to B, how much farther from the sun is Mars? It's around 80 million kilometers. For C, the average high temperature in Ottawa during September is around 20 degrees. And for D, how many more people live in Hunan? It's around 47 million. So you now do your jump math assignment, pages 22 to 25. When you're done, you're going to check in with me, and then you can go on to your extension activity if you choose.